Okay, I'm going to go ahead and get started. Unfortunately, no students are here yet, but hopefully they'll join me as we go through this week's chat's material. So I'm going to start in Chapter 1, and we're going to talk about the W's, interpreting data, becoming a better citizen, a more informed citizen. So let's go over some of the concepts in Chapter 1. Chapter 1 talks about the 6 W's. The who, the things being surveyed or the objects from which you're collecting the information, the cases that you're measuring. The what, the variables that you're measuring or collecting. When was the research or the study conducted? Where was the study conducted? What is the purpose of the experiment, and how was the experiment or the data collected? It's critical when you're working on a project with statistics where you're going to do some statistical interpretation. You must know the who, the what, and the why. Those are going to drive the types of analyses that you do and how you approach a problem. Hi, Caitlin. Can you let me know if you can hear? Can you hear? I'm talking now, so I'm going to find out if you can hear me, hopefully. And we just got started, so. Okay, great. Okay, I just got started. So we just started going over Chapter 1, and I talked about the 6 W's that are included in Chapter 1. So let's go ahead and keep going. There's a lot of definitions in this section. So the goal that when we do a statistical study or collect information is to be able to describe the population, or, as we'll learn later in the course, make an inference about the population. And usually it's impossible to collect information from the whole population. It's usually time doesn't allow it. It's expensive. We're going to learn in a minute about what it is when we do collect information from the whole population. But usually, instead of collecting information from the whole population, we're going to take a sample, and we're going to use that sample to make inferences about the population. And it's really, really important, and again, we'll learn this in Chapter 10, that the sample that we select is representative of the whole population. And this chapter also introduced the types of variables that you're going to learn about in this course. The categorical variables are variables that tell us the group or the category an individual belongs to. Things like gender, race, ethnicity, political affiliation, those are all categorical. Some other words you might hear for the categorical variables are nominal or qualitative. The drawback is that there's not a lot of computation that we can do with these, but we can use them to divide data into subsets. We'll learn more about that as we go through the course. Another kind of variable that we learn about in this chapter is quantitative, and this is numerical values, and we have units that are associated with a quantitative variable. We always need to know the units. So we talk about recording the amount or the degree of something. Some examples might be weights in ounces, money in dollars, temperature in degrees Fahrenheit. Those are all quantitative. The third kind of variable that your book talks about is an identifier variable. And we don't use that to describe the individual, but we use it to identify the case, so that if we need to go back later and collect more information, we know which case it came from. That's called an identifier variable. We don't do any statistics on an identifier variable. Okay, so let's go through some examples of the kinds of problems that you're going to see from this chapter. A pharmaceutical company conducts an experiment in which a subject takes 200 milligrams of a substance orally. The researchers measure how many minutes it takes for 1/4 of the substance to exit the bloodstream. And we want to know what kind of variables being measured here, and what, and if it's quantitative, the kind of unit. So what are they measuring in this study? What are they going to measure? They're measuring the minutes it takes, right? So is that a quantitative or a categorical variable? You want to try that one, Caitlin? Is it quantitative or categorical if we measure the minutes? Yeah, it's quantitative, right? And the units are just going to be the minutes. So that one's a pretty easy one. It's quantitative and it's minutes. How about this one? A Gallup poll asked, in politics today, do you consider yourself Republican, Democrat, Independent, or something else? So what kind of variable are they collecting there? Is it categorical or quantitative? Yeah, that one's categorical, definitely. Consumer Reports published an article evaluating refrigerators. It listed the model, the size, the type, and the annual energy cost. And there's actually 4 variables in here, aren't there? There's the model. So what kind of a variable would model be? Okay, actually it could be 2 different kinds when you think about it. It could be categorical, but it could also be an identifier, because maybe they put it down as the identity of that particular refrigerator. Sometimes you need a little more context. I put it down as identifier because I thought it would lead me then to know about the other information. So what about the size? What do you think about the size? What kind of variable is size? That one's going to be, yeah, that's quantitative, and right away here's your units right here, cubic feet. And then we had type and annual energy costs. So the type is going to be, and again you can see right away, there's categories, so that's just going to be categorical. And then energy cost, as soon as you see the word cost, you know you're going to be into quantitative, and the units are dollars. Okay, let's do another one. Are you feeling comfortable with this kind of a problem, or these types of problems in this chapter? Sort of. Okay, because I've got a few examples. So if you've had enough, let me know. There's the one, we want to do the W's. This is W's now. A study begun in 2011 examined the use of stem cells in treating 2 forms of diabetes. Each of the 40 patients entered one of 2 separate trials in which embryonic stem cells were used to treat the condition. The first question is, what's the who? What's the who for this particular scenario? Remember, the who is the things we're going to collect, the 40 patients. Very good. And if there's a specific number, it's good. And actually, these are also diabetic patients, so as much information as we can give is good. What? The what is the variables that they collected. So what kind of information are they going to collect on these patients who went into the trials? Okay. They're using the stem cells to treat the diabetes, and so what they're actually going to do, and this is where statistics problems sometimes frustrate some students. It doesn't always explicitly state. In this case, they're going to be looking at the effect of the treatments. Remember, they went into 2 different trials on the condition, and the condition here is actually diabetes. So the stem cells are actually the treatment, and we'll get to that in chapter 12. But what data are they going to collect? They're going to collect how does that treatment affect the diabetes. And I don't know how. They didn't really say what they're going to collect. Could be blood sugar, could be A1C, but they're going to look at the effect. When did they do it? Okay, this one's pretty clear on that one because it states it right in the problem. Yeah, 2011. Where did they do it? Now, many times they don't tell us. And this one doesn't say where. It doesn't say a state. It doesn't say a university or a hospital. So we would just say not given or not stated. Why did they do it? Why are they doing this? What do they want to figure out? They want to do something with the stem cells, right? So they want to see what's the effect of the stem cells on the diabetes. See if they could be used to treat the forms of diabetes. And then how did they do it? Okay, they don't really tell us here. They really don't tell us how they went about collecting this information. So many times on the W's, you won't have all the W's identified. But remember on the other slide, this might have been right before you came in, you always need to know the who, the what, and the why. Those are critical for you to then determine, if you were the statistician and you were going to summarize the data, how you summarize the data is really going to depend on the who, the what, and the why. Okay, here's one I pulled down off of, actually online. I looked at Arby's restaurant chain and the nutritional information for the sandwiches. And I know it's small to read, but basically they went through, I gave you 3 of their sandwiches, but all their sandwiches were up there. And they gave you all kinds of nutritional information and allergen information about the sandwiches. So what's the who in this problem? What's the who? Remember, the who is the things from which we collect the information. So what's the who here? Sandwiches. Very good. Excellent. Most students don't get that. The sandwiches at Arby's. And then what did they collect? All right, I'm not going to make you write them all, but they collected all this stuff here. All those variables. I don't even think I did write them all down, but the type of sandwich, because here's the type of sandwiches here, and then all this stuff up here. When did they do it? Okay, I don't think I gave you this, but here's when I did it. I came off of the website. I don't have it showing there. Oh, notice the units are provided too here. All these variables have units. I actually pulled this off of their website in November of 2013, and if you saw the whole website, that would be noted there. Where did I get it? Or where did they get it, actually? Where did I get it? I should tell you where I got it. I got it from the website. Why did they do this? Why did Arby's post this? Any idea? Why would they collect this information and then post it on their website? Any ideas? I always get different answers from students. I mean, a good answer is to help you make better choices. The other answer students like to tell me is the government made them do it, because I think this isn't new, a government regulation where they have to post this stuff. And then how. How, they didn't tell us how, not stated. So somehow they took the sandwiches into the laboratory, I guess, and determined all these things about the sandwiches. Okay, there's a whole series of questions on the same scenario here. So because of the difficulty of weighing a shark off the coast, researchers caught and measured 100 sharks, recorded their weight. Sometimes when I'm reading through here, I like to kind of underline things I might need. 100 sharks, their weight, their jaw width, their body length, and their sex. And they hope to find a way to estimate the weights from the other more easily determined quantities. So who? What's the who here? And this is a multiple choice. European sharks, 100 animals off the coast, 100 sharks. The information was not given. So what's the who? Yeah, the 100 sharks. Exactly. 100 sharks. And same scenario here. What was measured? So now, again, you're going into the what, which means the variables, and that's why, unfortunately, my underlining went away. But that's where we would do the weight, the jaw width, all that stuff. And that's B, you're right. When were the measurements taken? When did they measure them? And again, I mentioned sometimes they don't tell us, and this one doesn't give us any information on when. Where were they taken, the measurements? Where were they taken? Well, it tells us, it doesn't really tell us. It says they talk about the difficulty of weighing the sharks off the coast, but it doesn't really tell us where they took these measurements. So this is really not given. It does talk about the difficulty weighing them off the coast, but it doesn't really tell us where, because they probably didn't take the measurements off the coast. They probably did this in a laboratory, I would think. But why did they take the measurements? Why? They hope to find a way to estimate, and that's another C there. Find an easier way to estimate the weight of the shark. And then lastly, how did the researchers obtain their measurements? So where did they get those measurements from? They baited the sharks. They made estimates. Yeah, this is another C. They took it on the 100 sharks that they caught and measured. Okay. Okay, so that's all I had for Chapter 1. Quick review of that material. I know you worked on that during the last week, but it's good to go over it. Any questions on things I didn't cover? So Chapter 1 was basically the W's, types of variables, a little bit about reading a summary of a study to get an idea of how you might analyze the data as we work through the semester. And I think you're typing a question, so I'm going to wait for a minute. Okay, good. Okay, so let's go to Chapter 10, which got into types of sampling, more about populations and samples, methods for random sampling, and a little bit about survey design. And again, a lot of terminology here. So in Chapter 10, we talk about population and parameter. So if I'm going to collect if I'm talking about some attribute of a population, I call that a parameter. So if I'm talking about the average age of all the students at St. Petersburg College, if I talk about all the students, we call that a parameter. And if I take a sample and calculate the average age, that's what we call a statistic. And most of the time you're going to work with statistics. This chapter gives you 3 ideas about sampling. The first one is that we take a part of the whole, which is a sample. We randomize, somehow we randomly select the items in our sample, and then we talk about the sample size. And the sample size is really related to, let me go back for a second, is most importantly, it's not the fraction of the population, it's more about the actual size of the sample. As we work through the semester, you'll see that we talk about a sample size, and it leads into what we call precision and accuracy, and we'll learn about more of that later in the semester. But the census is where we get data from all the members of the population of interest. So in the United States, we do a census every 10 years. So the sampling methods that we use, we have SRS, which is a simple random sample. Every sample is equally likely. We can do a systematic sample where we choose every nth item or individual. We can do stratified, and this is where we divide the population, basically if you think about it, by a categorical variable, usually, homogeneous groups, and then we take a proportion, a sample from each of those groups. And then we have cluster sample, where the population is in representative clusters, and then we randomly select a cluster and sample every individual from that cluster. Multi-stage is where we combine the different methods up here in different forms, multi-stage. So we might do stratified and then do systematic within the strata, something like that. So multi-stage. And then the last type is called a convenience sample, which is not going to be a representative sample. This is where we get people that are easy to get. And these samples are always biased. Examples of these are, when you do one of those surveys online, a survey of the day on a website, those are what we call convenience samples. So what kind of biases can we see? We can see voluntary response bias. So when we collect a sample, let's say we do a survey, and voluntary response bias means we just take the answers from everybody who responds. And so people volunteer to respond. So sometimes, like, if you order something online and a little thing pops up and says, would you give us feedback on our online ordering system? The kinds of people that are going to respond to that are probably not representative of all the people that use the website, because the people that respond are probably going to be really happy with the service or really unhappy. So we call that voluntary response bias. Convenience sampling we just talked about. That's a bias. Bad sampling frame. The sampling frame, I didn't put that up on the earlier slide, but the sampling frame is the thing from which we draw the sample. And this might be where we just get the wrong list of people. Bad sampling frames can occur a lot of times in polling, like when we do polling for elections, and we draw the sample from the list of registered voters, but those voters may not be the people who actually vote on election day. So we're not really sampling from the correct sampling frame or population. Under coverage, we leave out part of the population. And then response bias is anything in the design of the survey that influences the responses. It can be the wording of the question, the sequence of the question. So it's something inherently flawed in the survey itself or the survey process. And then non-response is people who don't respond might be different from people who do. So that could be another bias. Okay, so let's do some terminology review. A magazine publisher mails a survey to every subscriber asking about the quality of the subscription service. 100 subscribers responded. Of those who responded, 56% reported the magazine was helpful. So the first question is, what's the sampling method that was used here? What kind of sample are they doing here? What kind of sampling strategy, or survey strategy maybe I should say? Did they really tell us that they took a sample? Notice what they said. They mailed the survey to every subscriber. No survey, right. And we call this actually an attempted census. So they're attempting to contact every subscriber, but they didn't get them all, obviously. But that can be called a sampling method, attempted census. You try to get everybody to respond. The total number of subscribers, the 100, what does that represent in terms of sampling terminology? The total number of subscribers, not the 100, sorry. All the subscribers represents the big picture, so that would be the the readers, but in terms of survey terminology, that would represent the population. Okay, so the whole population is all of their subscribers. And the proportion of subscribers who reported good quality is known as what? What do we call this? What is the thing that we're interested in when we do this survey? We call that the, remember what that's called? Well, we're not talking about the sample yet. This is actually where we're talking about the population parameter of interest. What they wanted to do was talk about the quality of the service. And so when we talk about the whole population, we call that a population parameter of interest. And then the 100 subscribers, here you go, Caitlin, this is known as this is the sample. And a listing of all the subscribers is known as, remember the thing from which we collect the sample, or is called the sampling frame. Excellent. Yep. I want to make a note to add that back here because for some reason I didn't see it on the slides I was showing you. So I want to make sure I add that back in for next time. The figure 56% is what? Is it a sample, a parameter, a statistic, or the population? So 56% was 56% of the 100 people said the magazine was helpful. So how would we what terminology would use? Is that a sample, a parameter? That's a statistic. Excellent. Yes, because it was calculated from the sample. Very good. Okay, so here's a bunch of statements about surveys, and there are different claims here, and I didn't go into this in great detail talking earlier, but we can talk about it as we go through this from your book, Just Checking. So the first statement says, why is each of the following claims not correct? It's always better to take a census than a sample. Always better to take a census than a sample. So what were some of the downsides that we said about the census? Not always accurate, right? And we also said what? It would take a lot of time and money. So it's really not good to say it's hard to reach people. Takes time. So we can't say as a blanket statement it's always better to take a census than a sample. How about this one? Stopping students on their way out of the cafeteria is a good way to sample if we want to know about the quality of the food there. What do you think about that one? Is that a good one? Good way to do that? Very good. Excellent. You must have done the problems in the book. It's a bias sample, definitely. If we drew a sample of 100 from 3,000 students in a school to get the same level of precision for a town of 30,000 residents, we would need a sample of 1,000. Now, I touched on it earlier where I said the size of the sample is not really, the size of the sample relative to the size of the population is not critical. What's more critical is the actual size of the sample. And again, in the second half of the course, we'll talk about precision and accuracy when we do inferential statistics. And so this is really not true. It's only the sample itself, the size of the sample, not the fraction sample. So it's possible that 100 people from the town of 30,000 is going to be just as precise as the 100 students from the 3,000. A poll taken at a statistics support website, garnered 12,000 plus responses. The majority said they enjoy doing statistics homework. With a sample that large, we can be pretty sure that most students, statistics students, feel this way too. What do you think about that one? It seems like it makes sense, right? We got overwhelming support here that they love to do their statistics homework. See any issues with that one? What kind of bias? Right, so what kind of bias would this be? Remember the types of bias we just talked about? It's a convenience sample. Not everybody uses the website. Yeah, it's a bias sample, and you could think about it as convenience and also response bias, because obviously the people that answer that survey probably are the people more likely to enjoy doing their statistics homework. So it's a bias sample. And lastly, the true percentage of all statistics students who enjoy homework is called a population statistic. Anything wrong with that? When we're talking about the population, what do we call the thing that we're calculating? We call it a population parameter. Remember we talked about population parameter? Population, and I try to get students to try to remember this. The P goes with the P, and the S goes with the S. So from the population, if we calculate a characteristic, we call it a parameter. If we calculate that characteristic from the sample, we call it a statistic. So P with P and S with S. Okay, here's a little scenario, and we're going to do 4 different proposed sampling strategies, and we want to name what they are. So we want to survey a random sample of the 300 passengers, there's our population, on a flight from San Francisco to Tokyo. Name each sampling methods described below. Pick every 10th passenger as the people board the plane. What kind of sampling would that be? Every 10th person as they board the plane. What would we call that kind of sampling? Systematic, yes. Very good. From the boarding list, randomly select 5 people from first class and 25 of the other passengers. So we've taken the 300 and we've divided them into first class and everybody else, and then we take a random sample from each of those groups. What do we call that kind of sampling? Stratified. Excellent. Very good. Randomly generate 30 seat numbers and survey the passengers who sit there. What kind of sampling would we call that one? Simple random. Very good. And then lastly, randomly select a seat position, right window, right center, right aisle, etc., and survey all the passengers sitting in those seats. That's cluster. Excellent. Very good. Very good. Okay, just a couple more on here to get you thinking a little bit about bias. Amusement park opened a new roller coaster. It is so popular that people are waiting for up to 2 hours for a 2-minute ride. Concerned about how patrons feel about this, they survey every 6th person in line for the roller coaster, starting from a randomly selected individual. So they're doing systematic sampling. The survey asked whether the patrons think it is worthwhile to wait a long time for the ride, and whether they'd like the amusement park to install still more roller coasters. What biases might cause a problem for this survey? What kind of biases are there with this particular survey situation? Hi, Lee, we're just going through the question. Well, we're talking about sampling now, so let's think about what's the problem with the way that we got the sample there. So they interviewed every 6th person in line for the roller coaster. Now remember, these people are waiting in line for up to 2 hours to ride on this roller coaster. So what's the problem here with the way they're taking the sample? Exactly. And so the way I would term this one is under coverage. They're missing all the people that don't want to wait in line. These are the people that are willing to wait for 2 hours. So we have some under coverage here because we didn't get any responses from people who are not willing to wait in line. How about this one? A popular soft drink company distributes written surveys with its product that a customer can fill out and mail in, or the survey can be filled out electronically or on the internet. And again, we're talking about identifying a bias here. What kind of bias do we have here? So they gave these surveys with the product. The customer can fill it out and mail it in, or it can be done online. What kind of bias? Think of the biases we had. We had under coverage, we had response bias, we had voluntary response bias, convenience. What do you think is the most, I don't want to say obvious, but the one that would probably skew the results the most? For this one, I would go with voluntary response bias, because people are volunteering to respond. We don't know anything about the question, so we can't really call it response bias, but voluntary response bias. People are volunteering to respond. And then an online newspaper conducted a survey by asking, do you support the lowering of air quality standards if it could cause the death of millions of innocent people from pollution-related diseases? Probably should say reduce, it's kind of weird wording, but what kind of bias is here? Think about this question wording. This is response bias. Very good. Yes. Look at the question wording. Okay, you're wording the question in such a way that you're probably going to influence people's responses, and we call that response bias. This I just thought was interesting because in the course I'll talk frequently, and in fact I think you guys are doing postings this week on polls and surveys. This is from the Gallup poll website. And at the end of the surveys, they always have this little box here that calls survey methods. And it'll tell you how they got the data, when they did it. This is kind of your W's here. So a couple questions. For the survey, identify the population of interest. So what's the population of interest here? It says that they took a random sample of over 13,000 adults aged 18 and older living in the 50 United States and the District of Columbia. They give you a really nice description here. So the population of interest must be this definition right here. That's who they're targeting. Adults 18 and older living in all 50 U.S. states and the District of Columbia. Gallup performs its surveys by phoning numbers generated at random by a computer program. What's the sampling frame? What are they drawing the telephone numbers from? Remember, the sampling frame is the thing from which we draw the sample. And it does say here, I didn't put that up here, but that's how they do these polls, telephone interviews. But they usually do random, what we call random digit dialing. Caitlin's got it, maybe. Let's see. What's the sampling frame? The thing from which we draw the sample. I didn't see anything come up, Caitlin, so I'm going to go ahead and put up just the telephone numbers. That's the sampling frame, because they don't know the names of the people when they call. They're doing it just on phone numbers. Do you see any problems with matching the sampling frame to the population of interest? Here's my population of interest. Here's my sampling frame. It's a random generated list of phone numbers. What do you think? Is there any mismatch there? Remember we said before, bad sampling frame can give us a bias in the study. So we see any problems with this? Yeah, those who don't have phone numbers. Some people may have more than one phone number. Are they using cell phones? So there's a lot of concerns here when the frame is not actually directly linked to the population of interest. We can get what we call, again, a bias based on bad sampling frame. Okay, so that was chapter 10, which talked about surveys, sampling methods, biases. Anybody have questions? And before we go on, the last one I'm going to do is chapter 11, which has to do with experiments and observational studies. Okay, Lee, are you okay? I hope, Lee, you can hear me. Good? Okay. Lee, can you hear me talking? I'm hoping. Okay, good. Okay, I just wanted to make sure. Okay, so chapter 11 was experiments and studies. And we're going to talk about observational studies, principles of experimental design, more terminology, and then some confounding and lurking variables. So what's an observational study? In an observational study, the researchers don't assign the choices. We simply observe what's going to happen in the groups. And we can have two different kinds of studies. Retrospective, where we look back. We identify something we're interested in, some population parameter, and then we look back in time at things that might have influenced it. So, for instance, here's an example. Researchers examined health records of thousands of males and found that men who died of a heart attack tended to be shorter than men who did not. Retrospective. So the men had died, and then they looked back to see what their height was. Prospective, we identify something we're interested in, and then we track it forward. Key words you'll see, just as a little clue here. Examining health records is a clue to it being retrospective. Prospective, among a group of disabled women aged 65 and older, those with a vitamin B12 deficiency, we have identified a thing we're interested in, were twice as likely to suffer from depression than those who did not. So again, we find the people with the deficiency, track them forward, compare them to women without. Prospective study. It's not possible for observational studies to prove cause and effect. Okay, we can only say there's a relationship that we observe, but we can't say that one thing causes the other. So in other words, because men are short, that's going to cause them to have a heart attack. Doesn't make any sense. Because these women had a vitamin B12 deficiency, it caused them to have more depression. We can't use that. We have to do an experiment to show cause and effect. Okay, an experiment manipulates factors to create treatments. randomly assigns the subjects to the treatment groups, and then compares the responses of the groups across the treatment level. Notice here the random part is not a random sample, but we randomly assign the treatments to the subject. So the randomness comes at a different point in an experiment. The explanatory variable is called a factor, and then we measure some response variable. So the thing that the researcher manipulates or changes is called the explanatory variable. There are 4 principles of experimental design in your book. Control. We want to control all the sources of variation other than what we're studying, so that we can be sure that what we see at the end of the study was caused by the treatments. And then the randomization, again, this allows us to equalize effects of other things that we don't even know about. That's why it's important that we randomly assign the treatments to the subjects. Replicate means you have a big enough sample size. So it might be that you do the study and then you repeat the study, or that you make sure you have enough subjects in your study. And the last thing that we can do is what's called block. We can group things or people with similar characteristics together and then randomize within each of the blocks. Of these 4 principles, blocking is not required. These 3 are required, blocking is not. It's a great thing to do, but you don't have to do it. Your experiment can still be valid even if you didn't block. Okay, so let's talk about controls. So a baseline measurement is called a control treatment, business as usual. It might be that we give a treatment, or it might be that we don't give anything. And if we don't give any treatment, we call that a placebo. And then sometimes we're going to blind. We don't want people to, if people knew what treatment they were getting, that might change the way they respond. And so we can do what's called blinding. We could have a single blind or a double blind. And by blinding, it means either the subjects or the people evaluating the results don't know what the treatments are. And then the fake treatment that looks just like the real treatment is called a placebo. So a single blind might be that just the subjects don't know. Or maybe the subjects know, but the people evaluating the results don't know. Double blind means both groups don't know. So surveys, again, I'm going to emphasize this. Surveys try to estimate population parameters, so the sample needs to be as representative of the population as possible. That's why we draw a random sample. In an experiment, we're trying to study the effects of the treatments, and the experimental units are not always drawn randomly. If we're looking at the effect of a drug on a particular disease, we're only going to include people who have that disease in the study. So the best experiments are randomized, comparative, double-blinded, placebo-controlled. This is the best, what we call the gold standard. Not all experiments are done that way, but that's what would be the best gold standard. Okay, so let's do some problems. All right, multiple choice on this group here. So over a 2-month period, among 20 people with a psychological disorder, patients who were given a high dose of a certain supplement improved more than those given a placebo. The researchers used a table of random numbers to determine if the patient would receive the supplement or the placebo. There's the randomization. And then they kept track of the dosages of the supplements and placebos. What are the experimental units? This is the WHO. What are the experimental units in this case? So A, B, C, or D? Anybody want to try? What are the experimental units? Remember, those are the things from which we're going to collect the information. Anybody want to try that? D. Yep. The 20 people with the disorder. How did the researchers randomize the treatments? How did they randomize the treatments? Now right here they told you they used a table of random numbers to determine if the patient would get the supplement or the placebo. So they used a table of random numbers. Many times they won't tell you how they actually did the randomization, but this time they did. Okay, different problem now. This is from your book. At one time, a method called gastric freezing was used to treat people with peptic ulcers. An inflatable bladder was inserted down the esophagus and into the stomach, and then a cold liquid was pumped into the bladder. Now you find the following notice on the internet site of a major insurance company. Our company, whatever it is, does not cover gastric freezing for chronic peptic ulcer disease. Gastric freezing for chronic peptic ulcer disease is a non-surgical treatment which was popular for about 20 years ago, but now is seldom performed. It has been abandoned due to a high complication rate, only temporary improvement experienced by patients, and a lack of effectiveness when tested by double-blind controlled clinical trials. What is the factor that they're studying here? When they talk about the studies that they did here, they did a controlled clinical trial. What factor were they studying? What was the treatment when they did this clinical trial? Okay, they're treating peptic ulcers, but they're actually trying to look at the type of the treatment. So if they did a double-blind controlled clinical trial, they must have looked at this gastric freezing compared to something else. So it says controlled, so there was some kind of a control group, which is probably what the standard of care might have been at the time. Or it could have also been a placebo. We don't know. What was the response variable? What kind of effect are they looking for? What are they treating here? They're treating these peptic ulcers, right? So what kind of an effect would they want to see? They would want to see, well, some kind of relief from the ulcer, right? I would think there's pain, improvement. Yeah, I don't have an ulcer, so I don't know what relief would be, but maybe no pain. And what were the treatments? What were the treatments? So we know one of the treatments has to be this gastric freezing, right? And then because it said control, there must have been a control group. And again, we don't know what that control group was. It could have been a placebo, quite honestly. They could have put a bladder down and then, it's hard to visualize this. I don't know if the people are awake when they do it. If the people were asleep, they actually could put the bladder down and not put any cold liquid in. By control here, I don't know. It could have just been I'm not sure because it says double blind too, so we don't have enough information. I think Lee was typing something in. How did the researchers decide which subjects received which treatment? How did they decide which subject? Probably like endoscopy. Oh yeah, you're right. And if it was endoscopy, they would be asleep. So, yeah, but see what bothers me? It still says double blind. So, kind of interesting. Double blind would mean the patient and the person evaluating wouldn't know. But the doctor could know who was doing it. Anyway, how did they decide which subjects received which treatment? Okay, now here's where we did a double-blind controlled clinical trial. So even though it doesn't actually say it, there was some kind of a random factor there. We don't know what the random assignment is, but these words here tell you there's some kind of a randomization. And then how did they, were the results statistically significant from the clinical trial? Here's your key here. They weren't, because they said there was a lack of effectiveness. No, there's the key words there, lack of effectiveness. Again, later in the semester, we'll see how they make decisions like that, where we actually do the data analysis that would support that. So here we go. What does it mean that the study was double-blinded? So we were just talking about that. It means what? It means that, neither the patient or the doctor who evaluated the patient knew what treatment they received. The doctor who treated the patient might know, okay, because remember, there's two levels of double blinding. The doctor who did the procedure could know, but the doctor who evaluates the patient doesn't know. Double blind, nor did the patient. Why would you recommend a placebo control? Why is it good to have a placebo control? Because you need this to do the blinding. Okay, if you're going to have blinding, you need to have a placebo. So these two words are always going to go together. Placebo control means it's blinded. Always going to go together like that. Let's see what other questions I had. Suppose the researchers suspect the effectiveness of the freezing might depend on how long the patient has been suffering from peptic ulcers. How could this be accomplished in the study design? So in other words, they think that maybe people who had the ulcer longer might be more likely, let's say, to benefit from gastric freezing. How could they build that into the study design? How could they build that in? Think of the 4 principles of experimental design. And there was one that we said was optional. So how could we incorporate that particular strategy into this experiment? Anybody have an idea? So how could we put that in there? So we could do some blocking, and we could block by the length of time they had the ulcer. So we could create one group that was, maybe less than a year, and then the other group might be more than a year. And then they would randomize the treatments within the less than a year group and within the more than a year group. And the length of time then is called the blocking factor. So this is a nice way that blocking can be put in there. If we don't think there's any effective time, then we don't need to block. We could also block, maybe we think men and women respond differently, so it could be blocked by gender. So this is a nice example of how blocking can be used quite effectively in a study. So confounding and lurking. When the levels of one factor are associated with levels of another, we say that the factors are confounded. And we're going to talk about this in an experiment. It's hard then to isolate the effect of one from the other. And I think I have an example coming up before. And this is in experiments. So we're going to reserve the word confounded to experiments. And we're going to reserve the word lurking to observational studies. A lurking variable creates an association between the other two that tempts us to think that one might cause the other. And I think... no, I don't have any examples here. An example in an experiment might be of confounding. Let's say we're interested in, let's say as an instructor, I'm interested in trying a new teaching method with my classes. So in my online stats class in the fall, I teach the students using my normal methodology. And then come spring, I'm going to implement some changes, use it in my courses online, and then compare the success rates from fall to spring. Okay, there's a confounding factor there, which is the time factor, because maybe the students in the fall are different from the students in the spring. And so there I would say that time and the effect of the new teaching method are confounded. I can't separate the effect of the teaching strategy from the effect of time. Lurking could be something like, one thing, I know you have problems on this, but one thing, if we look at elementary school students, students with larger feet have higher math scores on their FCATs. Okay, the lurking variable there could be their age. Okay, so lurking we're going to do in observational, and confounding we're going to talk about with experiments. Okay, let's take some examples here. An artisan wants to create pottery that has the appearance of age. He prepares several samples of clay with 4 different glazes, and he test fires them in a kiln at 3 different temperature settings. Is this an observational study or an experiment? Anybody want to try that one? Is that an observational study or an experiment? It's an experiment, absolutely. Definitely, because we're talking about different glazes and we're putting them in the kiln at different temperatures. What are the factors in the treatment? So what is he looking at here? He's looking at... actually looking at 2 different things, isn't he? He's looking at the glazes, and he's also looking at the... I think Caitlin's typing something in. Sure, I'm at the bottom here. Yeah. Yep. And actually, the total of treatments, the factors are the things we're working with, and then if you want to talk about treatments, it's all the combinations. So there's 4 glazes and 3 temperatures, so there's actually a total of 12 treatments. What's the response variable? What's the artisan going to measure to determine the effect? What's this response variable going to be? Yep, Lee. I think you were both typing at the same time. Yeah, it's right. Yeah, really the effect of the age. I don't know what that means, the appearance of the age. We didn't really define what that means, but that's what they're looking at. How does because he said he wanted to create pottery that has the appearance of age. What kind of conclusion can be reached? So when this artisan is all done, what's his kind of conclusion is he going to be able to come to? What's the information that he's going to get out of doing this experiment? Anybody want to try that one? Now again, this is where you're getting more into the interpretation. Work or doesn't. Well, you can even be more specific than that. Remember, he had 12 different treatments here. So what can he come up with out of that those 12 treatments, he could come out hopefully at the end and say, absolutely. Well, not what he wants, but which one's the best. Okay, because he wants to see the pottery with the appearance of age. By doing the 12 treatments, he looks at all of them, and then he actually can come out with the best combination of the glaze and the temperature. All right, so that was an experiment, and let's try another one. 90,000 women participated in a 16-year study of the role of vitamin folate in preventing colon cancer. Some of the women had family histories of colon cancer in close relatives. In this at-risk group, the incidence of colon cancer was cut in half among those who maintained a high folate intake. No difference was observed in those with no family-based risk, and this is from a Science article, 2002. Is this an observational study or an experiment? And if it's observational, is it prospective or retrospective? What do you think? So in deciding this, you've got to look at it and say, is the researcher influencing the outcome at all? Okay. Good. Oh. Very good. You both got it. Observational, prospective. Yes. Prospective, observational. Who were the subjects studied and how were they selected? So who were the subjects that were studied and how were they selected? And again, when you're talking about the who here, you want to be as specific as possible. So the who is, the women, the 90,000 women. And how were they selected? It doesn't tell us. Okay, a lot of times in these, they're not necessarily going to tell you. They probably invited them to participate, would be my guess. But it doesn't really tell us how they were selected. They're not randomly selected, though, probably. What's the parameter of interest? What is it that they're interested in looking at or measuring? Well, definitely the colon cancer, and they're actually looking at the incidence, remember, because it said the incidence of colon cancer was cut in half. So there's your population parameter of interest, the incidence of the colon cancer. And what was the nature and scope of the conclusions? Now, this is where it gets a little sticky, because remember, this is an observational study. So we can't say that increasing high folate or having a high folate intake is going to reduce the incidence of colon cancer, remember? Because we can't do cause and effect in an observational study. So all we can really say, let me see, Lee's going to type something in. Okay, I thought you were typing something in. All you can really say is minimize colon cancer, but we can say that high folate intake may be associated with lower cancer risk, but we can't say it actually reduces the risk. This is where you have to be really careful, because in today's media, I see so many studies of this type, and they'll come to the conclusion that this thing caused this thing, and we can't say that. There might be something else different about the women who had high folate intake. Maybe there's some other thing that we didn't measure, a lurking variable, that actually is more related to the fact that they had less colon cancer. We don't know, because they didn't give us information on that. Maybe the at-risk group already had more screenings than the people who weren't at risk. Anyway, you can't say one causes the other, so I just want to emphasize that. If it's an observational study, you can only talk about association, not causation. Okay, that is what I had for today. Anybody have questions on any things that I didn't actually cover? Now's your chance to ask questions. Okay, good, Caitlin. Okay, great. Okay, so next week, I don't have the syllabus in front of us. I think next week in the chat, we're going to do chapter 2 and 3, maybe 4. I can't remember how many chapters you have in this coming week. But I'll post the materials again ahead of time, and we'll have the chat at the same time next Wednesday. So everybody have a good week. If you have any problems when you're working on your My Stat Lab homework, you can email me or email me through my courses. Okay, so everybody have a great day, and I hope to see you next week.